Hello everyone. Uh, welcome to welcome back to the next part of the artificial intelligence video. I am Alagumina, assistant professor, Department of Information Technology in Fatima College. So, in the previous video, we learned what is AI, its history and its applications. I hope you understand those concepts carefully. So now in this video, we are going to understand how AI actually work. So don't worry, I will explain everything in a simple way with a real life example. Let's begin. So let's begin. First, let's understand agent and environment. What is meant by agent and what is meant by environment. So agent is nothing but anything that can take action, that is an agent. Then environment is nothing but then everything around the agent is an environment. That is, I repeat, an agent is anything that can take action. An environment is everything around the agent. For example, you are an agent and your surroundings are the environment. See, you are an agent and your surroundings are the environment. A robot is an agent for the example. So watch clearly. So the robot is an agent and the factory is its environment. An agent work using sensors and actuators. An agent that works using sensors and actuators. Sensors helps to observe and actuators helps to act. So agent mostly works with the using of sensors. So these sensors fully help for the observe the data for the actuators. For this example, so our eyes are sensors and hands are actuators. See this video. How agent works. Sensors helps to observe. That is, eyes are used to observe. Then actuators helps to act. That is, hands helps to act. So let's understand problem formulation. The next concept is formulation. That is problem formulations. What is meant by what is meant by the problem? The problem formulations means what? So which states are there? So next we move for this concept. So for this example, let us understand agent and environment. For this, then examples we also already saw the eyes and hands. Before we solving the problem, we must define it clearly. So what is meant by problem formulations? That is, in this section, the problem formulations have three parts. The first one is initial state, second one is goal state, then next one is action, then the last one is the cause. This is a result. So totally four parts. The first three works for the actions. So first state is initial state, then goal state, then action state, then cause state. So in initial states where the problems starts, is the initial state. Then the goal states are where we want to be. So where we want to go to be. So that is the goal state. That the action states, what we can do. So what's the purpose we can do? That is the action states. The last one is the cause states. What it takes. That's the cause state. For example, in Google Map, initial state is your location. Then goal state is destination. Action states or roads, and cost is distance. So these are the four states, four main concepts, four main parts for problem formulations. I repeat: initial state, goal state, action state, and cost state. In the real-time example, we taken the Google Maps. Initial state is your location, goal state is your destination, actions are roads, and cost is destinations. And now let's see the next concept, that is tree and graph structures. So tree and graph structures. Uh, Now let's see tree, what is meant by tree, and what is meant by graph structure. A tree is a simple structure with no loops. Tree is a simple structure with no loops, but graph is more complex and can have loops. So tree structure, a simple structure with no loops. For example, a family tree shows generation without cycle, that is a tree structure. In a graph structure, a more complex structure that can have loops, that is in example, social media connections form networks with cycles. So one of the best example is social media for the graph structure. Family tree is the best example for tree structure. So I repeat, a tree is a simple structure with no loops, but a graph is more complex and can have loops. Example, family tree, and the social media had for graph. So next, we will move on the concept of state space representation. So in state space representation, state space means all possible situations of a problem. That is what is meant by state. What is meant by state space? It means all possible situations of a problem. It means a state space representation. For example, in chess game, every board position is at state. So in chess board, it's had many positions are there. So every board position is a state. Finally, um, in search tree or a search graph, a search tree may repeat states and take more times. Search tree may repeat states and take more times, but search graph avoids repetitions and is more efficiency. So that is the main thing. So it shows in this picture. So I repeat, all possible confirmations or positions that a problem can be in state space. For example, chess, every possible board positions represents state in the game. A search tree may repeat states and take more time, and a search graph avoids repetitions and it's more efficient. So for example, in a maze, a tree may visit the same path again, but a graph avoids it. So today we learn how a works using agent, problems, and state space. So today we learn how agent works, how tree works, how graph works. So today we learn how A works using agent, problem, and state space. These concepts are very very important and understanding in A algorithms. So I conclude this concept. So today we see many important things, that is agent and environment. I conclude this. What is meant by agent? Agent is an entity that acts. Then environment is surroundings that uses the sensors, that is input, and actuators are the outputs. Then next we show the problem formulation concept, that is it's had four things, that is initial state, goal state, actions, and path cast. These are the problem formulations section. Then tree structure, it had no cycles and it's had a hierarchical concept. Then graph structure, it can have cycles, it's more flexible. Then last one is state space representation. All possible states of a problem is a states. In example, chess game. So search tree and graph we already seen. That is, a tree had a repeats states and the graph had avoids repetitions. In this key points, what's the final key point is a graph is more efficient than tree. So these are the main concepts of AI. Today in this video we learned about the concept of artificial intelligence based concepts, that is some agent, environment, what is what, then how it's used, what is meant by state space, and a tree concept, search tree concept, and a graph concept, and state space concept. These are we follow this concept. These are the very very important and interesting concept in AI. So I hope you all understand, and it's very useful for you. Uh, Thank you so much for watching this. Um, Thank you for